Okay, so we thought to find the stability of the system using root stability criteria. We've been given the characteristic equation and we're told to find how many poles of the system lie in the right half plane. So the first thing you want to do is you want to obtain the coefficient from here. That's 1, 2, 4, 6, 8. So the highest power is S4, probably S4, S3, S2, S1, and S0. The coefficients you write them as 1, 2, 4, 6, 8. Here just be 0. And then the remaining rows will obtain them. So now this is a reference for how each row is calculated. You can find this on my website, link below in the description. So to get this point, we're going to do 1 times 4. We're going to do 2 times 4 minus 1 times 6 all over 2. That's going to get you 1. So here is now 1. The next calculation to get this is 2 times 8 minus 1 times 0 all over 2, which will give you 8. So this will simply be 8. Now for this third row, it would have been 2 times what is here minus 1 times what is here, but in this case it's 0, so we don't need to go that far. Now for this next line, it's going to be, so now for this next line, it's going to be 1 times 6 minus 2 times 8 all over 1. That's going to give you minus 10. So now here we have minus 10. And for this point, it's supposed to be 1 times 0 minus 2 times 0 over 1. So that'll basically just be 0. So we don't need to do that. And then for this last row, it's going to be minus 10 times 8 minus 1 times 0. That's 1 times 0. 0 is here. All over minus 10. This is simply going to give you 8. So you can write 8 here. So now we have our first row. So we know the first row. We can now check for the stability. So 1, 2, 1 minus 10, 8. So you can see this positive, this positive, this positive, this negative, then this positive. So no sign change, no sign change. From here to here is one sign change. Then from here to here is another sign change. So don't get confused on how to count how many sign changes there. So in this case, there are two sign changes, which means that there are two poles lying on the right half of the S-plane. If I'm to draw it out, the root of this system is actually, so now this will be the poles drawn on the S-plane. This is obviously not drawn to scale, but you can see this is the right hand side, right? You can see there are two poles on the right hand side, which is from this particular pole. This system is most definitely unstable. Thank you for listening.